GitHub workshop materials, like just all the presentation stuff. Oh, do I need to start again? Is that
No, you're good. Continue.
okay? All right, yeah. So, hi everyone. Wait, I'm not sharing my screen. Stand by. All right. Can stop. Okay, seeing the slides. Great. All right. Round 3. Hi everyone. My name is Anish Asthana. I'm a senior software engineer with the AI Services Organization at Red Hat. I was previously with the AICoE. They just moved us over to PNT recently.
Hi, I'm Harshit. I'm working in AICoE in a team called PROTS, and you will come across this a lot of time. We handle AICI and the bots for most of our teams. Nice to meet you, and excited for presenting you the workshop.
Yeah, absolutely. Gosh, I don't know why I'm having some issues today. There you go. So, a quick intro to Git. Normally, I'd ask people to raise their hands if they've heard of Git or used it before, but that's a little more challenging now with all these screens. So I'll just dive into my examples. I'm sure most of you have seen Toy Story 2, or at least I hope you have. If not, it's a great movie. But one little neat story or fact about it is that the movie almost didn't happen. While they were working on the movie back in 1998, one of the animators, when he was just running through some routine delete operations, accidentally started deleting everything. This was a big problem because there's just one copy of all the files which everyone operated on. So there's just one system. So if someone accidentally starts deleting something, it gets deleted for everyone. They managed to shut all the file servers down. Luckily someone noticed it, but the problem ended up being that it was too late, and they lost 90% of the movie. To make things even better, all their backups had been failing silently for some time, so the movie was gone. Well, except for one little thing. One of the animators had started working from home. I think she was on maternity leave at the time, or she was about to go on maternity leave. So she had pretty much the entire movie, minus a few weeks of progress, in the system on her machine at home. Pixar ended up using that backup to bring the whole movie back to life. And they lost a few weeks, but that's okay. And they learned a lesson in keeping the backups running and maybe doing something better for version control and protecting the systems. So typically, version control, there's lots of different types of version control, right? Like there's SVN, there's Git. Every company has some different flavor that they like using. But in general, it's just something you use to store files and to track them. It's usually maintained by some people, who have full-time jobs for this. At Red Hat, for example, we have Gerrit and GitLab maintained by dedicated teams for each of them. And their jobs are not easy. They keep things running for all of us. And I think speaking from an open source perspective, or as a developer, the most interesting thing to me is being able to track all changes to files so that you know what the state of the project is as time has gone by. We'll dive a little bit more into this through the presentation. The why. Oh, someone wants to join. Yeah. Typically, right, coming from college, you don't really think about these sorts of bigger projects, right? Like most of our assignments at school or projects were just 1 or 2 people teams working on it, right? Like all you have to do is just create a version thing of your code, right? So you say project V1, project V2, project V3. I know I did that for lots of my projects in school. But obviously that isn't scalable at all when you're working in teams with 5 people, 10 people, or even hundreds of people, right? Depending on the project you're working in. Git version control makes it a lot easier to do that. It makes it easy for you to share your code, and it makes it easy for your co-workers or co-community members to know what you're doing. So there's a couple different kinds of version control. The first kind is no version control, which is sort of what Toy Story had at the time. You're working on your project, everything's going fine, and then you spill coffee on your laptop, it's all gone, and your professor is angry with you because you didn't turn your assignment in on time. Version 2 of version control is self-managed servers with for the technology you're using. So you can use Git, SVN, Mercurial, whatever. This is basically you have dedicated ops teams at your company or your organization that are running it for you. They'll have some failover, right? So if one of your Git servers goes down, it's okay. There's other backup servers. So work hopefully isn't lost, and you can keep working on whatever you want to do. The third kind is online cloud-based version control tools. So this is where your public GitHub, public GitLab come in. These are companies who, it's their full-time jobs to run these systems at scale. So they're very, very good at it. In your eyes, right? It's just all on the internet, right? You don't care about the specifics, and it's even easier for your companies to manage that. At Red Hat in general, depending on your project, you could be using any number of these. Like you could be using public GitHub or internal GitLab. We're going to ask a quick question. So I'm dropping a Google form link in chat. Let me know if that pulls up something for you. I guess the question is, how do you maintain security in large projects, large open source projects, I should say, or even not open source projects? Your options are using SSH keys, using GPG keys, neither of these, as in they both don't help, or both of them, as in they're both required. Let's give everyone like a minute or two to answer it. Don't worry, we're not actually tracking your answers. Your mentors will not be shaming you if you get anything wrong. So we have about 24 responses so far. Let's give people a few more minutes to respond. Come on, I wasn't that boring. Everyone can't be asleep already. We only had 30 responses. All right. 40. I think 40. We have 41 responses, which is good enough. Yeah, Harshad, good point. To clarify, this is about protecting the project from people who want to, slip malicious code in or something. Let's see if this works. Can you see this Google form? I'm assuming you can. Okay, cool. Thank you. Yeah. So we have a wide mix of answers here, right? Like 50, roughly half of you said both. 33% said SSH, and then fewer for the other ones. This may have been partially a trick question, but the answer is both. SSH and GPG keys both do different things for providing security. I think as you set them up later in the workshop, you'll find out more about the specifics. But in general, SSH keys are used for authenticating to servers, right? So instead of having to enter your password to connect to some version control system, you can use an SSH key that you set up beforehand. And GPG keys are used for signing your commits, which basically means like you put a tag on the, like whatever files you change, right? You sign off on it saying, hey, this was me. And the specifics of how they work are maybe not important, but I'm happy to dive into it a little more once we're done with the bulk of the presentation. So now with version control, we have a lot of terminology. So we'll be working through the most important ones through this, and we'll have some questions and stuff interspersed in this. So the first term you need to know is repository, or repo for short. It's just a collection of files. You can think of it almost like folders in your machines. They usually scope to a single project or a single product. But again, different teams, different organizations have different ways of organizing their repos. In general, this is just your base thing. Here's just a diagram that we'll be going back on a lot. So I hope you can see my mouse. But assuming that we're working on GitHub, you have your local system down here, and you have GitHub up top, like the GitHub servers. You're connecting to GitHub via the internet. We don't care about how it actually works. And on GitHub right now, there are 3 repos you care about: alpha, beta, and gamma. Now, having the repos up on some online system doesn't help you with working, right? You need to be able to get that repo and all of those contents onto your local system. You do this generally by cloning or checking out. And really, it's just the act of downloading files from the repo. It gives you a local copy of all of these files. And one key thing here is that any changes you make locally are not sent to like the upstream or the online repository until you specifically say so. This would protect you from situations like Toy Story, where you delete all of your local files, but it doesn't get pushed up unless you push it up on purpose. A lot of people use checkout and clone interchangeably, but they're a little different. In general, clone is just used for fetching repositories, so for downloading it. And checkout is used to go to a specific state for the repo. So one common use for checkout is like, I want to see what the repo looked like 2 months ago. You can do that with checkout. Again, you'll learn how to do all of this over time. So here we're back to our image. GitHub has their online things. We just run git clone alpha.git, and our client has all the repo contents in our system. Next thing we're going to talk about is pull. Conceptually, it's a little similar to clone in that you're getting the files from online. But to be more specific, it's the act of retrieving updates to the repo since your last update. What that means is that, say, someone else has made changes to the online repository, and you want them in your system, you can run a git pull command to get in all of those online changes. So going back to our example, we have alpha. Someone has changed these 2 files in the repo. We run a git pull command, and we download those 2 files to our system. And now both alpha, like online and offline, have the same copy of the repo. The next thing we're going to talk about is commit. Effectively, you can think of it as similar to saving. Basically, you make changes to your files, you save it on your system, but that doesn't tell Git that it should save those changes in its version tracking history. So what you do is you run a git commit command, and some of the information associated with the commit is who made the commit, when you made the commit, and other useful context you can put in. So you can see, updating ABC to be of color red or whatever. One little fun fact is that it can be used as both a noun and a verb. And what that means is that I can say, hey, I'm going to commit all my changes. Or I can say, Harshad, you raised a pull request. There's this one commit on that pull request, which is completely broken. Fix it. So here what we're doing is the user changes a file and saves it, and then they make a commit, which saves it to their local Git history. Key thing here is that it's not being pushed upstream, right? It's not being pushed online. It's only in their local copy. You can see we committed, nothing's changed. Now, the next step is obviously getting your changes online, right? Like there's no point in you working on amazing features or new whatever without having other people look at it. So you do that with the git push command. I keep saying git push. In general, all of these concepts apply to any version control system. Git is just the one that's most frequently used. So I keep defaulting to Git. So, here again, the user is making some changes. They're committing them. They then run git push so that all the commits that are on their local system and that haven't been pushed since the last time they pushed go up. And now you can see that both the server and the client have the same view of all the files. Next up, we have one more question. I'm dropping a link in chat. The question is like, which of these commands should you run to create a copy of the repository? Should you run git clone, git pull, git fetch, or git checkout? We'll give everyone like a minute to work on it. So let's say by 1:31, oh, sorry, 1:21. If you have any questions, just feel free to drop them in chat or just save them for after the presentation. And again, happy to answer anything. All right. We're at about 40 responses, which I think is good enough. I'm not going to share it this time because almost everyone got it right. They said git clone. The few people, well, the two answers we got were git clone and git checkout. Again, just to drive that difference in, git clone is for initial download of the repo, and git checkout is just to go, once you have downloaded the repo, you can use git checkout to go to a specific time in the repo or state. Next, we'll start diving a little bit into the general workflow for using version control. Say as a user, you're working on your latest version of the repo. Other people from your team have made changes and they've pushed them up onto the server's copy of the repository. I make some changes locally. I add them, I commit them, and then I try pushing them. But wait, Git will actually, or most version control systems will stop you right there. The reason for this is that the version control system knows that you haven't pushed, that there are changes in the online on the server that aren't in your system. So how you get around this is by first running git pull so that you and the online repo have the same state of the repository. You test it, make sure it's working still, and then you try pushing it up. And you just run git push. Everyone's happy now. Now, I thought someone, oh, yeah, go ahead, Gauravi. You meant to click on that.
Hi, Anish.
Yeah.
Yes. So my question is like, let's say on my local copy, on my client copy, I'm doing some changes and I do not have the latest copy as that of server, like alpha.
Yeah.
And so Git will definitely not allow me to push my changes to the server. Then I have to get the latest copy from server and then do the changes. So basically now I have two copies, one with my own changes without latest changes and second copy from server which has latest changes. So I have to like rewrite or merge these two things and then push it to back to server.
Yeah, good point. So when you run git pull, right, it downloads all the changes that are made to all the files. So you won't
Okay.
end up with two copies, more so that Git will automatically change all the files that you have in your local copy. So if, for example, let's going back a little bit, right?
Yeah.
Let's say this is file B, right? It's
Mm-hmm.
changed online, but it's not in yours. When you run git pull, and I'm simplifying a little bit here. When you run git pull, it will automatically overwrite this file with this file.
Okay.
Okay. Now, there's something like known as merge conflicts, which we'll talk about later. But say,
Okay.
as you were working, you made changes to this file as well at the same time as like there were online changes, right? And you run git
Mm-hmm.
pull. It won't overwrite whatever files you have changed. It will ask you,
Oh.
hey, like there was this file was changed in two locations, right? Like by two people,
Mm-hmm.
like by the server and the client.
Okay.
What change should I accept, basically? And so that requires
Okay.
manual intervention. So
Okay.
in most cases, it automatically takes care of it for you. I guess is the short answer.
Okay. Okay. And my follow-up question is based on your answer. Let's say like file B and C are different on server and I'm making changes on file E and F, like
Yep.
those purple and those orange.
Yep. Yep.
At client, I'm also making the same, like I'm also making the changes on same files, like let's say B and C blocks.
Yeah. Okay.
So
So
when, yeah.
okay. So basically, alpha like server changes go to B and C, and alpha changes also go. I mean, client changes also go to B and
Mhm.
C, right? So
Yeah.
these ones. So
Yeah.
that point, that's when you have to be careful. Basically, you will run a git pull or you do a rebase or whatever. Again,
Mhm.
we'll talk more about this later. Basically, you'll be able to choose what changes you're taking and how you're merging all the changes together.
Okay.
It requires more manual intervention. I'm talking a lot right now. I think it'll be easier when you have a terminal in front of you and you're actually
Mhm.
doing it. But there's ways around it, I guess.
Okay. Okay. Thank you. Thank you so much, Anish.
Yeah.
Yeah.
I don't want to steal all of Harshad's thunder. So, yeah. So moving on to tag. So right at the beginning, right, I said, okay, when you're working on your projects, you can have something like project V1, project V2, project V3, whatever, right? Like project final, and like all of that. You can think of tags as basically the same thing. It's just a snapshot of the state of the repository at some given point of time. It's not a separate copy, so it's not like you'll end up with two copies of the same files on your system. But it's a way for Git to know, okay, here's what all the files looked at this point of time. So if that's a good way for you to checkpoint it, right? So if you're working on a product or whatever, typically most projects will have tags associated to each release. So like v0.0.1, v0.0.2, and so on. So again, let's say we're in a world where all files in your repo have their own version number, and these version numbers are very simple. They just increment by one each time a change is made to it. That's not actually the case in real systems, but let's say that is the case. Lots of files have been changed. Something's going to V11, V32, V16. and so on. Now, at this given point of time, we say, okay, hey, the project is complete, it's feature complete for version 1. I create a tagged release called v1.0.0. And then development continues to go on in the repo, right? Like once you release v1, that doesn't mean you're done. So as the files continue to change, this tag which we created, which is called release 1.0.0.0, yeah, will continue to be pointed at the repo as at this point of time, right? You can do whatever you want. This will not change, short of deleting the repo or something crazy like that. But we're assuming no one's doing anything like that. Your repo can have multiple tags, like I said. So you can have release 1, you can have release 2, release 3, and as many as you want. Now I think we're going to come to one of the key concepts with version control, which is branching. Basically, it affords you a way to have 2 parallel tracks to develop in a single repo. Changes that are made in one branch are not present in other branches. And you can merge branches and you can create branches as and when you feel like it. Depends on the team, organization, whatever. But typically, most people will use branches to work on either for larger features or to support old versions of the project. Now, speaking of branches, every repo will have like one main or key branch. So, terminology again, right? So it could be main, it could be head, it could be trunk. A lot of projects used to use master as like the main branch, but recently the terminology has shifted, and most projects use main as a way to refer to that. No 2 teams do things the same way here. So again, you learn as you go along. Cool. So say we're at this point of time right now. We create a new branch called new feature, right? You do get checkout be a new feature. Again, we'll talk more about creating branches later. Don't worry about the specific command. Now you end up with 2 branches like main and new feature. Development keeps going on both branches in parallel. Say I'm Manish, right? And I'm working here, but my team members keep working on the main branch, or they keep getting commits in. After some point, when I think that my feature is ready, you can just merge the branch in. So at that point, everything just comes together and you have all the changes you want in main. Now, in general, going back to the tags example, branch, your main branch will basically be the newest version of the files on your system, on your repo. That isn't always the case, but in general, that's the case. Whenever you want to use something from a repo, you'll be referring to a specific tag in it. So anytime you clone a new repo, you get the contents of main or master or whatever convention that project has chosen. Now, if you run git checkout a specific tag, what you end up getting is the repo at that point of time, right? Which is a good way to just look at the history of a project. So I know this slide says Git now, and we've kind of been talking about Git so far, but let's go into some specific details about Git, which make it nice. It's a distributed version control system. The alternative is, well, I forget the word you use, but the other one is centralized version control systems, which I think SVN is one of them. Commits are usually made to your local copy of the repo, and you explicitly have to push them up later. With Git, branching is cheap, it's easy, and it's very easy to shoot yourself in the foot with all the branches you can create. Going to the file versions, like I said, right? File versions are not incremented by one every time. They're actually they're hashed. This kind of gives you some more confidence in the state of the files as time goes by. Git is also very complicated to get started with or to use it well. It's very easy to break everything. And generally, I've definitely been in lots of situations like that where I said, okay, screw it, I'm starting over. I just copy my files over and then I try figuring out the Git again later. It's probably one of the most popular tools used right now in a large number of companies. GitHub is just a free website for using, for storing your repos on. You can have private repos on it, but generally most projects don't. It's publicly accessible. It can be a great resume reference, right? Like that's one of the great things about working in open source. When you go for an interview, you can say, hey, like, go onto GitHub. I've contributed to these projects. You can literally look at my code right now, which I think is pretty cool. It does let you support organizations, which I'm sure some of you have already started being added to your team or organizations. Others will be added soon. You can share ownership, and you can do all of that admin stuff that you need to do with any project. And there's a lot of repos on there. For Wikipedia, as of January of last year, there's over 190 billion public repos, and I'm sure that number has grown. So that's why we've been talking about repos, right? The repo we've been referring to is the primary copy of the repo. Forks are a way for you to create a personal copy of the repo, which lives under your namespace on the GitHub server. You can think of it, I think it'll be easier to explain with the diagram, so we'll get to that in a few minutes. But basically, it's just your own copy of the repo that's stored on your namespace on the server itself. Again, like with your local upstream copy, changes don't go anywhere unless you tell them to go somewhere. The last main concept you need to worry about is pull requests or merge requests or patching, whatever. Really, it's just referring to like, hey, I've made these changes. Will you pull my changes into your repo? So generally, the workflow will be like, I push changes up to my fork, and then I open. Jenny, we'll get to that in a minute. The next diagram. Yeah, so you make changes in your fork, and then you open a pull request to upstream, and then the upstream owners of the repo can review your code, make sure it looks okay, and then merge it in. So let's say here, H-Nalla here refers to Harshad, but Harshad has a repo called Gamma that I want to contribute to. What I'll first do is I will create a fork of his repo on GitHub. Again, it's very easy through the UI. And what that does is it creates a copy of Harshad's repo under my name in GitHub. Then what I'll do is, Harshad's repo continues developing on the side. No changes get made to my fork unless I specifically pull them in. Then what I'll do is I'll clone this repo onto my local system. I'll make commits, I'll make changes here. I'll push it up to my copy of the system. And then I'll open a pull request from my fork to Harshad's copy of the repo. This is when Harshad will start reviewing it and saying, okay, hey, you need to make changes to this file, this code, this is terrible. What are you doing? That kind of stuff. Once Harshad is happy as a maintainer, he'll merge it in. Now, we got a question about forking versus branching. It's a good question. So to some extent, it depends on the project you're working on and sort of the team. In general, though, any open source project that you're working on, you'll need to create a fork first, by default, basically. The reason for that is that if you're pushing up to your copy of a branch on a repo, right? Like you might accidentally break something, or you can clutter up a lot of things on the like the primary copy of the repository. So most projects require you to create forks first. Now, when you create a fork and you pull it onto your local system, right? By default, or like git clone, by default, you have the main branch on your system. The main branch is, in theory, something that's stable and working, right? Like if main is already broken, that's a different problem. But let's assume that it's definitely working and stable. Now, if you're making any changes, right, you don't want to mess with main because it's working for sure. So what you do is you create a new branch or like new feature, and you make your changes in that branch. The advantage of this is that, say you have to work on multiple features at the same time that are unrelated, you can have main as like a safe starting point for all your changes. The other point is also that, like, if in your branch you break some things, you always have main to go back to and look at, right? If you're working directly on main, it becomes a lot more challenging to fix these issues. I hope that makes sense. If not, like, okay, cool. All right, last question. We haven't, I don't think we actually covered this material yet, but like, just instinctually, what do you think? How do you check the current state of your repository? Do you run Git Status, Git Diff, Git Check, or Git Log? Okay.
I have a question.
Yeah,
Can I
go
ask?
ahead. Yep.
Okay, so let's say I'm working on an open source project. I get the code from some organization's GitHub, right? So the first thing that I would do is to fork it and bring it under, let's say, Red Hat's GitHub, right? And once I have that inside the Red Hat's GitHub account, whichever my team is using, then that becomes my main branch, right? So I don't want to make changes to that. Is that what you're saying? So I do a branch first and then pull it?
Okay, so just to give an example on a repo that I somewhat frequently work with, right? Say this is like the main copy of the repo, right? Like it's called AICoE CD. This is the thing, right? Now in the GitHub UI, you can press the fork button. I already have a fork, so I won't be doing that. And I have my copy of this repo, right? So like say this is my fork of the repo. Now in here, I can pull the code, like clone this code onto my local system and then work on it. Now this gets more complicated when you have even more upstream downstream relationships, right? So to give an example of Openshift, I don't know if you guys know what Openshift is yet, but like let's just say, right? So there's one like upstream project called Kubernetes, which is like the primary source. Then Red Hat has a fork, a downstream, let's call it, of Kubernetes called Openshift, right? And now as an individual contributor to Openshift, you will be creating a fork from Openshift for you to do your own feature work on. These relationships can get very complicated, right? Now, say if I have to work on a pull request for upstream Kubernetes, how am I going to do that? And like juggling all of those different like repositories that you need to send pull requests to or changes to or basic changes on can be very challenging. I don't have a good answer for that beyond like you're just going to have experience as you work on it. One second. Right. All right, we have just one question. What KD with Openshift and Kubernetes? I don't feel comfortable answering the question because it's but as I understand it, it's KD is just like it's like the open source version. Everything open source, but like I don't have a good answer. Other than that, I well, people that. But.
Anish, I think we're not able to hear you clearly.
string. Oh,
There's like a little bit of a lag.
should I shut the camera off? Does that help at all?
A little bit.
I think you should try. I mean, it sounds like there's some stutter, so you could probably try logging out and logging back in. If not, I'd say your CPU probably needs cooling.
That's the point. I'll join back.
While Anish is joining, just to answer that question, upstream, downstream, midstream. So like he explained, Kubernetes would be considered upstream. OpenShift would be considered somewhat like you can call it midstream, and then you yourself call yourself a downstream. And now someone has asked where would the OKD fit? It would be a parallel midstream. It would be something sibling to OpenShift, and then you can fork from there as well. So fork is basically like a chain, and you can chain it. Basically, you can how you put domino puzzles, like you keep on adding stuff like that. You can just put like that and create your own chain as long you want. So someone can fork from you, and from you I can fork, from me Anish can fork, like that. It's like a chain. But from anywhere you can push, make a pull request to any of the upper versions of the inside the chain. You can make a pull request to any of them. So in that way, you will always be able to join that chain. Do you sign in through your Red Hat credentials by using GitHub, or do you have your accounts? So that question, like we will answer through, like when we are doing the workshop, we'll go through each and everything single. So right now we recommend you to have your Red Hat credentials added to your GitHub so that you can use that for your personal thing, for Red Hat stuff, and your personal credential for your personal stuff. I'll answer these questions while we are taking the workshop. I think Anish is back. He'll take over.
Can you hear me right?
Yeah, I think so.
Do I sound good enough?
Keep talking, I guess. We'll figure out.
Okay. Yeah. Okay. Cool. Yeah. So I guess question.
No, it's still happening.
This one.
Yeah. Let me check if I have the slide. Let me take over from there.
Anish, are you on desktop or are you on a laptop?
Laptop.
No, it sounds like your processor is just overheating and starting the thermal throttle.
Probably that. It is pretty warm. I sent you the slide.
Yeah, I think I got it. So we went to the you were in the question, right? Okay.
Yeah, slide 70. So
okay, yeah. So I'll share my screen. Just let me know if it's working.
Will do.
Can you see it?
Yes.
Yeah, I think you've gone a little ahead.
Ahead? I thought you were here.
Oh yeah, okay. I know. I think my system's just really laggy. Yeah, you're good.
Awesome. I think everyone answered this question. How do you check the state of your repository? Then Git status will give you the status, like what it is, where it is, which state are you in. There is I'll just go through one by one on each of them so that you just know what's the difference. The Git difference will show you difference between two files or multiple files, difference between branches. So you can check if two branches have different files which have changed. So it will show you that as well. Git check is basically like a checkout. You can check out to a branch, check out to a tag, check out to a commit. So like that. And then Git log can also be used for your state, because if you do Git log, it will show you all the commits which are there. So I guess from there also you can intuitively know, oh, this is where I am at right now. So that could be also a right answer. So going forward, let's go through some of the important commands which you will be using day to day while using Git. There's git log. Like I said, git log will show you all the list of commits in a branch. So if you do git log on your command line, you will see each commit in in a series of commits, and each commit will show you with details of a SHA, the person who is the author, his email, his or her email address, and then and then the commits message. So each commit has a message which will help others to know what you have done it in that commit, so that, and some signatures if you have embedded it in it. So it helps you look through what is happening in a branch. Then the next one is the git remote. I would say this one is a very important command, because through this, the whole question was which came up before, like upstream, midstream, downstream. How would we take care of that in your local system? This would be the command which would be your friend with to manage this. So you can set basically a pointer. So you see the word upstream there. That's a pointer. Like so that pointer will point to your URL, whichever you define. So here we are saying my repository is the upstream. So you basically are setting that you're setting a report pointer called upstream to my repository. So and then you can use the git fetch to get all the information for my repository. So that's how it works. So for example, whenever you clone a repository, it automatically sets a remote called origin. Origin is a pointer to the cloned repository. So if you have cloned a repository of Anish, your origin will be pointing to Anish. So, but if you have forked the repository first and then cloned it to your local system, then the origin will be pointing to your fork. Then next command is the git rebase. So earlier someone asked the question, if I made a change in my branch, and while I did that, the master or the main branch went ahead, and now I want to make a pull request to that, but my commit, I have already made changes, but I don't have those commits in my particular branch. What will I do? Answer to that is like pull with rebase, like you're pulling with rebase. So you can see what's happening here is basically we're saying, let's go fetch the information from upstream, what all changes are there, and then you're saying rebase, let me rebase this branch with that upstream. So you are doing git rebase upstream master. It's basically saying pull the master changes to my branch. So that is essentially what it is saying. So the command git rebase upstream master is basically pulling the master, like the changes in the master to your branch. And then push is already explained. It's like pushing your code to the server side. And then there are a few other things like squashing, editing, and dropping. We will go through this, but just to give you an example, squashing means if you have 10 commits at once, and suppose you think, oh, all these 10 commits are making commits which are made in a single file, but I can explain it in one commit. So basically, you squash those 10 commits into one, and then you explain that in your commit message. So essentially, you will do that. And that is very important when you're contributing to the team, because what you're making changes, it will be like, it should be neat so that others can understand. And also sometimes what happens is when your code goes into production and there is an issue, then it would make it easier if there is only one commit, because then we can just check out to the previous commit and the production will be running smoothly. But if you have pushed 10 commits, and then the DevOps side or the DevOps people have to figure out which commit is breaking it and then inform you. So it's a good practice to squash your commits to a single. So like so each team follows their own, but some teams says like if you're working on a feature, please provide one commit per feature. If you're working on a fix, please provide one commit per fix. So like that. Some teams also allow like multiple commits for a feature, but a single commit for a fix. So like that. So it depends on the team. Once you go into your team, they will explain what they require, or like in your pull request, they will explain you that. But squashing basically means squashing the 10 commits or 20 commits into one. So multiple commits into one. Now let's go through hosted services. We have already gone through this. We know there is GitHub, GitLab, and there's another one called Bitbucket. All of these are free ones, so you can use your own version of them. Most of them also come with enterprise versions, which you will see while you're working in Red Hat. And if you want, you can also purchase them. But free versions are available, and you can also do your private repositories now, so it will be private for only you, and no one else can see it unless until you give them privileges. So now this will after this we'll go into workshop mode, and let's do this together so that we can follow this through. Some of you, if this is something we added here just to know, like GitHub has new features like putting your portfolio into GitHub. If you would like to do that, there is some information here, and you can follow through these links and add to that. So it basically shows your README and your details. So yeah, I think this is our last topic. We're talking about open source. There are a lot of open source projects right now, and Red Hat contributes to most of them and also encourages the interns to do that. So if you feel like, oh, there's something you are really interested in, you would like to work on the normal time, please do try to do that. There are a few here, like there's the GitHub open source. I have linked that, and you can see most of the open source projects listed there. Hacktoberfest is one where you can get where you can contribute. Like Oktoberfest is really for the newcomers, so no one, like you, even if you feel pressured that, oh, I don't know anything, I have to work, I have to, like, I don't know if I can contribute, you can use this one, because in this they everyone lists their Git first commit, like first users, so you can go to that label and check that out and try to contribute to it. There are others, and at the bottom, we have listed two projects of our own teams. There's Open Data Hub, Station. Station is where I work in. Open Data Hub, where Anisha is contributing. There are other three teams, Operate First, AI Ops, and the AICoE itself, so you can work on that too. That's about it from the presentation. And if you have any questions specific to this, you can ask now, or else we can go ahead with the workshop and get started with it if you have your PCs and laptop in front of you. So I'll stop this sharing. Do you think we should take a minute or two, Anish?
Yeah, I think let's give people like say 5 minutes to just get water, stretch their legs a bit, and we can start it.
Yeah. Sure. Yeah, please do take 2-3 minutes and get back, and we'll start. So what's the time right now? It's 12:55. Let's say to take 2 minutes and 12. Oh, sorry. It's let's in 2 minutes. Let's start again. And if someone has questions, please just do ask him. Feel free to interact.
Just to be clear though, the workshop as a whole is not over. We will be resuming in 2 minutes. I think 1 or 2 people just left. They might also be bored, but this is just a presentation as bit that's over.
Actually, I had a question.
Yes, please.
Out of all of the departments at Red Hat, who would you say like uses GitHub the most?
I think all of them uses GitHub.
Oh.
So that would be a very tough thing to say that this team uses the most. But yeah, everyone uses that. Some teams are pretty private, so like security team and any production team, so they will go. They use GitLab, so GitLab, Enterprise GitLab. So I guess they are the only people who are not using GitHub, but most of the other teams are on GitHub.
Thank you.
while everyone is getting in, I'll just start sharing my screen, and whoever wants to start, like, please get to this part, and I'll still wait for another minute. Just wanted to check my screen share. Anish, you there?
I can see your screen, Harshad.
Yeah. I'll just toggle once. Hima, just let me know if you can see my terminal, okay?
Yeah, sure.
So you see my terminal?
Yes, I see it.
Do you see the color fine, or should I change anything?
No, I see it good.
Font and anything else?
Yes, it's good. Do you want to just run some command just so that I can? Yeah, it looks good.
Okay, thanks. Thank you. I guess we can get started. I hope everyone is in front of their PCs. So at this time being, while I'm on the screen, I won't be able to read the text, but Anish will be. So Anish, Hima will help out with the answers, like in the chat. But if you have any questions, like specific question you want to ask, I guess just speak out and just let me know if you have question, and I can answer while going through this, because I just have one PC right now. I don't have multiple screens to see right now. So I'll just go through this. I hope everyone is ready now. Let's go through this. At the beginning of the, Anish, can you paste the link again, or I can do that, I guess.
Okay.
Oh yeah, you're here, right? Okay. So this is the actual boot, like the workshop repository. So we will go through this, the whole process one by one, and let's go through each step. So I just wanted to share this so that if you have any difficulty viewing my screen, you can open it up in your screen at this, like, aside, right? So let's start with step 0. This is where like I said, we will go through this and we'll help you out. If anyone has not used GitHub or GitLab, anything at all, don't worry about it. This is like we are starting from the scratch. And if someone has done it and you think, oh, I already know this, I don't want to wait, you can go along and do the experiments. Or else if you want to wait and see what we are doing, that's also great. So let's start. First of all, if someone doesn't have an account, they can just go to github.com. So I'll show you that. So I have this. I'll open it up here. So you go to github.com and you should see a screen like this. If you click on sign up, it will show you some details. You just need to put username, email address, and password. So what I would suggest you is, please use a professional username. Even if you want to put something, like, put it on your own discretion, but I would suggest like putting something professional, like your name and or your anything with a alphanumeric thing, like your name or a date of birth, like do that. Putting anything else, like, I wouldn't recommend that, because you will be contributing to a lot of places, and it would be just be nice from your side if people can recognize you by your username. So I would just suggest that. In your email address, I would suggest put your personal email address right now. Don't put your Red Hat email address. And then rest of the things you already know, put your own password and then create an account. The reason why I'm saying put your personal email address is just because this account you can use like in multiple places. Suppose you want to work on your own project, it would be nice to have your own email address in there. And I will also explain how to get your Red Hat email credentials in there and how to use it on your own PCs, which are provided by Red Hat. So we can go to the next step now. If someone is going through this, keep on doing it. I'll just wait for 30 more seconds if you are. So I hope everyone has an account, at least an account in GitHub now. So let's go and set up credentials so that you can set up. Okay. Yeah. You see my screen, I hope so.
Yeah, we can see your screen.
Yeah, sorry. So now we will go and set up the secondary email, which would be the Red Hat email address. So this is my account. You can see, like, I have set up my account. It will look something like this. If you're a new account, you wouldn't have any image or anything right now, but you can add up everything later. So you click on your right side, there will be settings. If you go to settings, you can go to the profile, right? And here there are emails, email account, I think. And this, so in the emails, you can set up multiple email addresses. So I said keep the primary email address as your personal one, so that you can, if you use any other different PCs, then you can configure that with this email address. And for the internship, you can configure with your Red Hat email address. So just add your email address here and click on add. Rest of the things you can just keep the same. You don't need to make it as a backup, or you don't need to make it as a primary email address. You can keep it this way. We will show you how to configure it in your systems as well. So just add that. I hope everyone would have. I think everyone has gone through the NHO. So orientation, they must have given you your email addresses. You can add that. I hope everyone has done that. Now let's go to the next step. As you have done that, now let's set up Git in your local system. I think Red Hat provides all these 3 operating systems based on which teams you're working on. So currently my team, like where I'm working, I use a Fedora operating system. If anyone is using Mac, please look through the Mac commands. I'll go through them too, but I won't be able to show it to you like practically, but you can go through them. We have defined that in the workshop, and same for the Windows. So let's check if Git is available. If someone has already installed it, they should be. So you can just do git -- version, and you will see the Git version installed on your system. If it's not, then we'll go to the next step of installing it. So we have to find the commands here to install them. So in Fedora, you have these commands. Dfnf install will do the to install the Git in your system. And for Mac, you would have to go through the installer and then install via brew. I think for Git for Windows, there is a exe file available in this site. You can just double click on it and it will install Git in your system. Take a minute or so just to do this, because from here onwards, this is something which needs to be configured in your system, and I don't want to miss out on anyone. So please take your time and have this.
Could you repeat that step, please?
This step, so to install Git, you can follow this based on your operating systems. So in your system, if your system is Fedora, you can use this command to install Git. And Ubuntu, you can do this. If you have Mac OS, you can go to this website and then install via brew. And for Windows, there is an exe file available in this site, and you can install that as well. So I was just saying I'll wait for everyone to at least install Git so that we can go through rest of the stuff together. And once you have done that, you can check if your Git is installed by doing the git -- version and seeing if it's available. And you should see some version. You don't necessarily see the same version here. I have an older Git. You probably would have a newer Git version. And please let me know if I'm not clear, and if you want me to talk slowly or anything, please.
Hey, Harshan, can you tell which web page are you on right now?
I'm on step 0.
All right.
I'm on step 0. The file is called 0 setup, and then I'm on step 0.4. Sorry.
Oh, I was just going to say, if anybody's lost on the initial link that was sent, you click on step, or it's one of the files that's in the repository that you click on. It's not in the first README.
Oh, Harshad, so go back to the repo. Just show how you read this file again. So yeah.
So this is a repo. The first file is the 0 setup.md. And this is, in this, we are on step 0.4. Thanks for letting everyone know. Thank you. Is anyone still installing this? Can they comment if anyone is doing that?
Yeah, I'm still working, sorry.
Please, yeah, take it. So while our friend is doing this, let me just browse through again what the steps which we have followed. First thing which we did was create a GitHub account. I showed you can go to this website and create that, put your information there, use your your personal email address, and then once you've done that, go to settings and then add a secondary email address that would be your Red Hat email ID. Once you have done that, you can go to your terminal. They're based to go to terminal in Windows. There's a PowerShell. You can go there, and then you can check for the version by stating git version, and it will pop out or prompt you a version. It could be anywhere new. It could be a different version because there are a lot of new versions which are available. And once you're done, if this doesn't show up, then you can install it from here. Like they're defined based on operating systems.
Hey, Harshad, so I downloaded from the link for Mac OS, and the package that I downloaded, it says that it cannot run because Mac OS cannot verify if that's free from malware. It's the Intel Universal Mavericks package, like. Yeah.
This, see.
Usually Mac is pretty paranoid about it. Do you have?
All right, I can try the command. Yeah.
Yeah, as I was saying, see if you have brew on your system, and if you install that brew, it should be much easier.
All right, thank you.
And if not this, we have defined that command for brew as well.
I'm all done with my install now, so you don't need to keep waiting for me.
Awesome, thank you. I'll just wait for another 30 seconds if anyone is still waiting. And if you have any issues, please let us know. Maybe we can help you.
Yeah, Harshad, this is Gauravi.
Yeah.
So I believe for rel, we would be able to replicate the same commands like using yum or rpm, right?
Yes, you can follow the same commands as Fedora. So you can just do yum install or dnf install.
Okay, perfect. Thank you.
I hope everyone has GitHub installed and Git installed in their system, and they could verify by doing git version. Just verify if it's available and if it's working. Just do this, and it should prompt you this message. Yeah.
I'm sorry for asking this. I just got stuck here. So I ran the last command for installing Homebrew, right? And it asked me to enter my password, and I did that. And now I ran the brew install git, and it still says the command not found.
Do you not have enough space on your computer?
It should. I mean, I just set that up, so it's right. I mean, I just got it. I did not have anything on it. So,
Mohammed, I think let's hop on a separate call. I'll just ping you right now.
All right.
You can share your screen and we can see if we can figure out what's going on.
All right. Thank you.
Yep.
I guess while Anish is helping him, we can go to the next step. So in the next step, we'll configure Git into your local system. So we did it on the server side. We added your email address there. Now we need to configure on your system. So we'll follow this procedure. So first, what we need to do is we need to define the name and the email address. So why this is important is this will define what name or email address should show up in your commit message. So in the commit, it will be author is always defined and author is picked from this information. So let's do that. So you can copy this from here. Once you copy this, then you can go to your terminal again. Then you can do git config and then basically paste the whole thing there. And instead of Jane Doe, you write your own name. So I'll write my name. And once you're done that, press enter. So I have already set it up. So yeah, I'll do it together, noise. And then we do the same thing with email address. And then that would be like, and here you will set it up for your Red Hat email ID. So when you're using it your own personal systems, you can set it up with your own personal email IDs. You don't need to do that. You don't need to put Red Hat email address there. You can put your personal IDs in their own systems. In your for Red Hat work, you can do it with your Red Hat email ID. Once you do this, you can check if it's set by doing git config --list, and it will show you your email, your name and your email ID. We will also set up other things one by one. If everyone has done this and has no issues and they can see their name and email ID, that's great. And make sure it's in Red Hat email ID in your Red Hat system. I hope everyone followed that step. You can set up from here. I'll go to the next step now. Hello? Yep. Hello?
Yeah, we can hear you.
All right. Did Mohammed get it? Like how to install?
Yeah, it's just taking some time to install. He should be good.
Okay, so we can wait for a second more, for a minute more.
I think it's going to take some time to install. You guys can go ahead. I'll just keep watching it and follow along. Thank you.
Yeah, I'll just explain the second step again so that you also follow through. So once the installation is done, the next step which we need to do is to configure Git on your local system, like configure it with your own email ID. So what the steps you need to do is basically you can copy this and then edit that to your name. And then you can do the same for the email ID and you put your Red Hat email ID there. Once you have done this, you can verify this by doing git config --list and it will show you your name and email ID. So just follow that step.
All right, thank you.
Awesome, yeah. So I'll go slowly to the next step. Please let me know if you have any issues. We can come back to it and go through this again. So step 6, please let me know if you have any issues with this, because this is more important, like because you will be using, you will just set it up once and you will with this you will work. So if you have any issue with setup, please let us know so we can help you out with this. So next thing is to configure the SSH connection with GitHub. So there was a question earlier, like how do you secure your source code? And there is an option for SSH and GPG. So let's go through SSH key. SSH key will basically have an encryption public and private key, and you will give that public key and you will set it up with your server side. So in the GitHub, when you have an account, that account will have a public key added to it, which we'll create right now, and that will always have it will always check if it's the right person who is making the changes. So for example, if I have set up my own private key, have created my own SSH key, no one else can push to my code or my source code without using my private key. So they have to have my private key. So in this way, we secure that no one can basically be me or and try to contribute to code saying that Sarshad. So that in this way, we are securing that one pathway of getting some unknown user pushing the code who the team doesn't know. So let's do that. So normally a SSH key stays in a folder which is on your root directory, and you can look it up by doing the ls command. So ls command is basically list, and it will list all the files which are in a directory. So we are going to use ls minus la. La means list all the files in the directory which is on your root. So it's root is basically tilde sign / and then there is a folder called .ssh. So if you do like this, for me there are a lot of SSH keys available here, but I'm sure like if it's your new laptop and no SSH keys set up, you will just have these 3 things showing up. So let's go and set up the SSH key and create one. So the command to create a new SSH key is available here. It's keygen, and then we are using the RSA method of inscription. So SSH hyphen keygen, then T as RSA. We are using the RSA method, and then you can put your email IDs for recognition. So you're basically saying, give me a SSH key with a TSA with an RSA encryption, and use my email address to basically add that to the SSH key so that it knows that it's belonged to you. Once you create this, it will prompt you this, like where should the file stay. If it's your first time creating SSH key, you can just press enter and it will go to this default location, or you can give it a proper location. So always on the root. So your name, your thing, your home, your name, and then SSH folder which exists, and then you can name it differently. So for example, for this, it is for workshops. So I'll just name it.
I may have missed a point over here.
Yes.
So I was typing ls space -al, right?
Yeah, it's fine. If you type after dash, you can put LA or AL. It's the ordering doesn't matter. It just basically says you want to see all the files and you want to be listed them in order. So the L is the order, A is the all after hyphen. Yeah.
So I received the message that no such files or directory. So is it?
So okay, I'll just finish this. I'm in middle of this. I'll just show you right after this. 1 second.
All right. Thank you.
So you basically create the SSH key by doing this. It will show you where to put that SSH key, and you can go for the default or you can create the one. So normally I put a clear name so that I remember what it is. So this is for GitHub. So I'll just put GitHub. It is already existing in mine. So you can use GitHub. I'll just use, I'll also use GitHub with a double B so that no one gets confused. Just put GitHub, and then I normally don't put any passphrase, but if you want it more secured and every time you want to be secure in that way, you can put a passphrase as well, which it will ask you whenever you're using this SSH key. And then basically it's the same thing, just follow through this step, and then you can see it has created a SSH key for me, and it will do the same for you. Just to answer the previous question, so I'll just show you the command. It's ls. I hope you can see my screen. It's ls minus la. You can do al, it doesn't matter, or forget about this, just do ls. And basically it's present on your root directory. So it's normally, I don't know which system are you using, but if it's a Fedora or a RHEL, it will be on your home. Then you can put your initial name or the Kerberos name which you have stated in your system, and you can press tab, it will show you that. And once you do that, put dot and then do S and then press tab. It will show you if the folder is existing. There should be a folder like this, and there should be files like this. And as you can see, I just created the private key, sorry, the SSH key. So it gave me a private and a public key for that. Can you just acknowledge if you can see your files there?
No, actually. So I went into my home user ID and I tried to click the tab and there's no SSH key.
Dot SSH dot.
Yeah, dot SSH.
So which system are you, like what operating system?
I'm in RHEL.
You're using RHEL?
RHEL, yeah.
Surya, can you copy paste the command into chat?
Okay.
Can others view it, or is anyone else also having the same issue? Did everyone follow this? And got their own?
I already had an SSH key for GitHub, so I didn't follow the steps specifically.
Awesome. If you have it, yeah. If someone already has that, you don't need to follow any like these steps. Only for the people who are doing it for the first time, and you don't have an SSH key encrypted or added to your GitHub. Just follow this.
Well, what did you say the passphrase? Is that like the password?
Yeah, and normally I leave it empty so that it doesn't prompt me again and again. But if you want to put, you can put it as anything, like as a password.
Thanks.
Yeah, but it's not necessary.
Sorry, I had to drop out in the middle because my internet being funny. But I'm at the step where I did ls dash al tilde slash dot ssh.
Yes.
And I got a total of 24.
Okay, so you have something inside it.
Yes.
You don't need to worry about it. Have you used SSH? Have you added an SSH key to your GitHub?
No, I don't think so.
So you can just create a new one and basically just use this command SSH key generation. Then you're putting the encryption and then use your own email ID, and then just put a different name, because I think if you already have some of it existing, then I think the default might have been already taken. Just put a new name to it. Maybe put it as a GitHub.
Okay, got it. Thanks.
Yeah, awesome. Anish, you taking care of the last issue?
Yeah, I'm talking to Surya. Yeah. So Jenny asked a question. Is the purpose of setting up the SSH and GPG keys for encrypting your commits?
Yes, it is. So it's not there will be GPG key there, like not SSH. GPG key will tell you this commit is not encrypting, but signatured with you. So that will say encryption, like encrypting a source code is something different that you can do with multiple other tools, which is available open source. So you can do that. But here, the essential use for SSH and GPG key is to protect your identity and say that the contribution is coming from you. It's you who's doing it. So the SSH will protect the system. It will say whoever is working from this system is the real user and is sending the commit. And the GPG key will basically suggest that whoever is using the system, it's you, because then in that it will prompt you a password to be put in, and you will put that password in.
Yeah, so in a way, you can think of GPG key as almost like a signature on a check, except it's basically impossible to fake. So if you're signing off on a commit with your GPG key, you use something called your private GPG key to sign the commit, and it's basically impossible for someone else to pretend to be you. So in general, using GPG to sign all your commits, while not strictly necessary on all repos, it's still recommended. And by default, I always sign all of my commits, for example.
So if everyone is still this point where they have gotten a cheap SSH key created, let's go through and the next step and configure it into GitHub. So as you can see, there's a public key here and there's a private key. So you don't share the private key with anyone else. Only the public key is the one which you will share. So you can go to GitHub, go to your profile, go to settings, go to SSH and GPG key, and then on the SSH key part, click on new SSH key, add any title. Normally you can say it's your Red Hat workstation, put the public key here. You can copy the public key as you want. You can do VI from Vim or cat command or less command, like whichever command you feel useful. Just view that and then you can put that here. So I'll follow the same step and show you how to do it. So you can do VI and it's in SSH. And it's GitHub with double B for me and then public. So I will use this. As you can see, you can copy this and then put it here, right here, and then write it as something like this, and then add the key. And it will prompt you to put your password. You can do that. Once you have done that, it will show you like this. And whenever you will use it, it will show you what was the last time you used it. I hope everyone gets to this point. And if you're having issues or anything, you can ask. Just to go through it again, the SSH key, when you're defining it, you only use public key, which is suffixed with pub, as you can see here, and you just open that and copy that one and then put it here. As you can see, there are multiple SSH key for me. I'll just go through them, like why I set up multiple of them. So there is one for my Red Hat laptop. There is one for my personal laptop. So like that, I've segregated them. So whenever I'm working from my own personal laptop, it will use this SSH key to verify it's me. And when I'm using from my Red Hat laptop, it will verify based on this SSH key, that's me. Once we are at this stage, we have successfully added SSH key to our system. Another use case of this is basically in terms of cloning. While you're cloning your projects, there is two options. There's via HTTP and via SSH. While you're doing to clone this via SSH method, it will basically tunnel you through the GitHub production, and it will basically say it already knows that it's you, and it will let you clone it properly without any passphrase or any password to be put in. The HTTP method will prompt you to put your username and password along with if you have added your 2FA, two-factor authentication, then it will also prompt you to put the token. So this is like a easier method to clone stuff while you're working on it. You don't need to put on your GitHub password again and again. But if you feel like that's better, then you can follow that method. If you feel this is better, you can follow this method, where SSH key will essentially configure or basically secure your system and the GitHub and the interaction between them. I hope everyone reached to this point. If you have any questions, feel free to speak up in the middle.
So Chu asked you to show the process again. Chu, from where do you want to see?
I'll show it from the beginning. It's fine. So you can do the ls command to see if there is a SSH key available. Like if there are SSH keys in your system, the reason why you're doing this is just to see if there is a default already present. If the default is already present, you need to change the name. That's why I was showing you to just look at it. And once you have done that, you go through this process. You use the second command to create a SSH key. So you put SSH key gen, that's the command. Then you're using the RSA method, and then you can put your email ID. That would be the Red Hat email ID. Once you do that, if you already had SSH keys in your system, you should rename or you should create this as a different SSH key and name it GitHub so that you know this is for GitHub. And you will follow the same step while you're working on GitLab, Bitbucket, or anything. You have to add, if you want to add SSH key there, you can create the different SSH key, so that you have separation between GitHub and GitLab. And suppose one day you need to delete the GitLab one, it wouldn't affect you in GitHub. So you can follow that as well, have separate ones. So once you have done that, you will have two files which will get created in your system. One would be with no suffix, and another would be with suffix pub. So this is your public key and this is your private key. If you open it up, you'll see this starts with SSH and RSA method, and it would say at the end it will be your email address. But this one will state I think it's a 64-bit or I think 256-bit character code, which will be basically be your private token, which you will not share with anyone else. So once you have this, you can do the ls again. You'll see they are being created. Once you do that, you open the public key, go to GitHub, go to settings.
1 second. I'm sorry to interrupt you. Can you go back for 1 second?
Yeah.
Can you go back up where you said home/HNALLA? Was that your username that you had for?
Yeah. So if you are getting confused based on this, just use tilde, like this sign.
Yeah.
Sign, and then put SSH, then put the name GitHub. You can use that too.
Okay.
Yeah. If you're getting confused on that, I was just doing that so that you can know that you put it's in your home directory, your name, like your username, and then that file. It will show you up here like what's the default one, so you can just copy this and change the last bit of it.
Okay.
Yeah.
Oh, you're using your home directory. Okay.
Yep. So once everyone has done this, try to do SSH -t github.git. Like I'll paste this command there in the chat if I have not pasted it in here. Yeah, it's not there. So you can just use this command, try copy paste that and see if it states your name and says you are successfully authenticated.
I get a command that says no such file or directory.
So when you use tilde as well.
Mm-hmm.
So can you go to like your terminal and just do like when you do tilde SSH, what does it show?
Tilde. Do I put tilde slash or just tilde?
Tilde slash, yeah, slash
dot
space,
SSH.
yeah.
It says permission denied.
Are you on RHEL?
No, I am currently on my MacBook.
Aisha, I think let's hop on a call.
Yeah. I'm sorry.
No worries. That's like it's much easier in person, right?
Yeah.
I've dropped a link in chat. Join that room.
Maybe you could just use sudo, just check in that way. Anyone else having trouble?
Yeah, when I do VI, the command doesn't work, but my SSH key exists.
So you can do cat command. You can do cat SSH GitHub wv and it will prompt you this. Yeah, this command always exists. I think we missed to be installed, but you can use this.
Okay, thank you.
Yeah, sure. And can everyone can everyone try this one, the SSHD, the one which I posted in the chat? And if it doesn't prompt your name, it means it hasn't been configured in your GitHub properly. Just check that. I will assume that everyone is okay with and they are ready and set with the SSH key. If not, please let me know. I'll go to the next step, which is step 7, which is to configure GPG key. So GPG key is basically setting up your signature, and this signature will help your commits to know that it's you, and this will always prompt you a password. So while configuring this, use a password which you remember. So let's see if you have. So this is a command to see if there's existing ones. If you already have existing ones, you can use them. If not, let's go and start creating a new one. Let's start this process of creating a new one. So there is a command called gpg full key generator. There's gpg full key generator. Once you press enter on this, it will basically ask, what do you do? You can use the default methods here. There's no wrong method, there's no right method. If you strongly feel about some other encryption, like the DSM encryption, go for that. But I would just recommend just to use the default ones. And then you can also use the default key size byte. And then for the expiration, if you think you're just going to if you just want that to be for your internship, you can put those days. Or if you don't want it to be expired, you can do that. And then at the end of the internship, you can just delete it. You can do that too. So I'll just let it be not expiring at all. Then do you feel correct everything? Yes. Once you've done this, it will ask for your name. You can write the name. Once you do that, it will ask for your email address. You can put your Red Hat email address. Once you do that, it will ask for any comment. You can put anything. I think it doesn't necessarily have anything to do. So it is just prompting you that you have selected your user ID to be like your name and your email address. And if you feel okay, just press okay. And now it is asking for a passphrase. This is the passphrase which you need to remember, because it will prompt you while you're making any commits. And this is how it knows that you are the one using this GPG key. So remember what you're typing it here and the password. Once you have done that, you will be prompted with your public ID and everything. I hope everyone has reached to this point. I'll just go through it again. So we created using.
If we need to download the GPG tools, which ones do we download?
So there's a link here to download and install GPG key. There's a link here, and you can follow this and you can install from there. And it is also defined based on your OS.
So we do the binary releases?
Yeah, you can do that.
Okay.
For the real name, do you actually put the real name, or do you put the GitHub ID?
You can put your email, your real name or GitHub ID. This is just for you to know this is you. This will not cause any issues. The passphrase, I think those are the things you need to put, which will differ. But you just make sure you're putting your name and email ID.
Gotcha.
So I'll just go through it again. If I missed someone here, so you can use that command which is already existing. You can copy that, and it's basically GPG full generate key. Once you do that, it'll ask you a few questions. What kind of encryption model you want, you can use the default one there. Then what key size do you want? You can use the default one. It will ask you how long do you want it to be for expiration, and you can choose based on this if you want for number of days, weeks, a month, or do want to be expired. You can do the default one and then delete it if you don't need it later. That will prompt you the name, email address, do the same, put your name and email address. Once you have done that, it will ask for a passphrase. Please remember that passphrase, what you're putting, because we prompt it again and again once we start using the GPG key. Once you've done that, it will give you a GPG key out. So next step one, what we do is we configure GPG key and then into GitHub on the server side. So let's go to that part. Same thing. We will go and go to settings and put the GPG key there. So for this, we need the long form of the GPG key. So you can check for the GPG key here. It will prompt you something like this. Or if it's already, like if you're seeing this, basically this is what you will, this is the value which it will spit out again. So you will just put this. Yeah, I have multiple ones. So this is the last one. As you can see, it has the same value what it is here. We're just getting that. Once you have this, you use this export command to export it. So you use export and put this here. Then use this to find the end of it. Copy this, paste it here. It will give you the public key like this. You can copy this public key. Once you copy the public key, go to your GitHub, go to settings, go to GPG key, SSH key and GPG key. Come to the GPG key part of it, add a new GPG key, paste it here, and then add it. Once you have done that, you will see two of them, like one of them, like a new GPG key here. Once you are done this, you are good to go. And how this will help, or how you will figure out that you are the one, your GPG key is being used, is when you make commits. So for example, I made a commit here. And this commit has something, my name, my commit number, right? And you see this verified button. This verified button will show up whenever you make a commit if you have GPG keys added to your system or you're configured to your GitHub. So this will say your GPG key number. So it's saying, oh, this is the one you've been using. So it authenticates you and says the person who is committing is the right person, because it will prompt your number, your password, and you will put the password, and that's how it will figure out you are the authenticated user. And it will show up in your commits that it's from authenticated user. So this is, in some of the teams, this is required to have a verified account, or else your commits will not be merged if it's not verified. So try to have this added up in your account so that you don't face those issues. So we were on the step 7. We just basically created a new key with this command. Once we did that, we copied the part from the full key generation and got the public key with this command. Once we got that, we added it to our GPG key, and now you're set. You can also set it to your configuration. You can do git config global and then put the same key. So this part is git config. We did that for the configuration, so you can do that to same thing here. So you use this and then you put your same key which you had here, this part of it, and you paste it and press enter. Once you have done this, you can see your config list, and it will have your key set up for you. So this key will match what I showed you here. This key. Any confusion, anything missed, please let me know so that I can go back and show you. All right. So if you have followed the whole steps here, we have done 3 things here: install Git into a local system, configured it with our name, email ID, and our with our credentials, and then we set up SSH and GPG key for verification and authentication of our user. So once we have done this, now we can go to the actual working of Git and go through them. So I will go to the next step, which is on the first, creating a repository and working through it. So let's go through them. So go to your repository or go to your account. And then there's 2 ways to do this. You either can go to your profile, go to your profile, and then you can go to repositories, create a new repository from here, or else you can click the right side plus button. There is a plus button that says, do you want to create a new repository? And we say yes. So in the new repository, we are creating a new repository called My Awesome Repository, or you can say GitHub Workshop. Follow this, just follow this one. And we are creating the repo. And this is the repo which we'll work on. So we'll keep it public for now. We want everyone to see what's happening here. There is some default option which GitHub provides if you want to readme, git ignore, or if you want to choose a license. So you can do that. You can add a readmes and git ignore. Git ignore is basically saying what kind of files you don't want to be committed. For example, if anything's ending with .txt, if you don't want that, you can add that to your git ignore, and Git will always ignore any files which are with .txt extension. So, and the choosing the license, there are multiple licenses which you can follow, and you can choose them. So once you're done that, let's create a repository. Now GitHub prompts us with these methods. Now what we need to do is get this repository into our local and start working with it. As you can see, there is HTTP and SSH method. As we have set up SSH, we'll use the SSH method. But if you can also use HTTP. If you use HTTP method, you would always have to prompt. It will always prompt you to put the password in. So you have to put the GitHub password on each commit, on each push. So you will use the SSH key, SSH method, and clone, basically copy that, and we'll create a clone of it in our system. So either you can follow this methods or any of these methods, but what we will do is first clone this. So what we'll do is go to repository and do clone command. So it's pretty similar. It's git clone and then that repository URL. Once you clone that, it was empty repository. I have some repository. Once you have cloned it, I'll show it again. Once you've cloned it, there would be a directory created with that repository, and you can go inside it with cd command. So cd means change directory. You're changing the directory to my awesome repository, and now we'll work in here. First and foremost command which you should always use is git status. So git status will show you if there is any changes or not. So as you can see, there is no changes. So it means there's nothing, and now we need to work on it, or we can work on it. So what we will do is we have cloned it. Anyone has questions? Sorry. So we have cloned it. We have changed the directory. Now we are basically checking if anything is there. And you can use the ls command to see if there's anything. There's nothing right now. If someone has ticked the readme license or anything, you should see readme license or the git ignore page of it. Any confusion till here? So this is how you clone a repository, like creating a repository and then cloning a repository. Any project which you clone will have the button called clone, and it will show you HTTP or SSH. We have used SSH method because we have set up SSH, or else you can use HTTP with your username and password. If no questions, let's go to the next step, which is making changes. So we will create files, commit them, and see how this works. So once we have cloned the repository, let's create a file called question.txt and put a question, any question, like for example, we'll put what makes you excited about programming. So you'll create a file. You can use editors if you have editors like Atom, VS Code, anything you can use. Feel free to use that. If you want to use just plain terminal, you can follow me. If like someone said their VI is not working, you can install Vim with TNF, and that will give you Vim. Or you can use gedit. Gedit is also a command to open files. So first we'll open one file, which is question.txt. And then we will try to edit it. So I'll also explain you how Vim works, if that will make it easy. So you use insert button, or you can do escape I, which will show you insert. So in the insert mode, you can write in that file. So we will post that question which we had asked, what makes you exciting about programming. So once you have written that question, let's save that. So in Vim, it's escape : W means to write, and then Q means to quit. So we are basically writing and then quitting this file. So we have written that. Now we have a question inside that file. How would we know that this file is existing in Git or not? So for that, we'll use again the status command. So this status command normally comes very handy to you. You can always click on that and see what's happening at that moment or that state of your repository. So with Git status, we got to see that there is an untracked file. So untracked file shows up in red. Basically, it's saying this file, Git doesn't know about this file. There is a file, but it doesn't know about it. So what would we do? We would add that file. So we'll do git add and the file name. So git add question.txt and then press enter. Once you have done this, you can do again git status, and now it would be under the tracked ones. So now this is tracked. It knows there is a new file question.txt with some content, and now it says the local Git knows that there is a file, but now the server side doesn't. So what should I do? I would go and commit it. So I will commit this file by doing git commit -m and then the message. So there are other things which you can also do in the commit. You can use -s, I think, to do add a signature. But right now, let's just be simple and do git commit -m. M means message, and we'll put a message. So commit messages are to be written in a way so that users can or the contributors can see the commit message and think, okay, what's happening in that particular commit. So here we are adding the question.txt. So we will just mention that added question.txt. Once you do that, as we added the GPG key, it will prompt you to put the GPG key passphrase. I'm sure you would have remembered your passphrases, so you put that. Once you do that, it will prompt you that your Git commit has been added. How do we see what happened now? You can go to the Git status again, and it will show you there is no more changes. I'll stop at this point and go and see if someone has questions till this. If anyone had any trouble creating it, adding a file to it, and you can also do git log to see you have a new commit here. Any questions till this point?
So when I commit, it doesn't pop up for the GPG key password. Is that normal, or is that an identity figure?
If I understand it correctly, you said when you do the commit, it doesn't prompt you GPG key passphrase. Is that the question?
Yes, that's the question.
Yeah. So it means either you have not configured your GitHub GPG key properly, or you have missed your passphrase encryption to that GPG key. So you would have to set that up again and do this again. So let's check through that, right, one by one. So have you created a GPG key?
Yes.
Yeah. So did you add that to your GitHub?
Yeah.
Okay. Did you do this step, git config?
Yeah.
User? Okay. If you do git list, does it show you your sign-in key?
So I should type in the.
Oh, you should type in git config -- list.
Okay, let me check. Yeah, there's a sign-in key.
There is the sign-in key?
Yeah.
Okay. So when you did a commit, it did not prompt you the GPG issue, right? It did not show you any passphrase.
No.
Okay, let's try the next step, and then if you still don't see anything, let me know, and I'll walk through you, okay? Work with you on this. So as you have, yeah, sorry.
Sorry, the directions say that if you had cloned using the SSH URL, that it would push directly to the remote URL, and like, I thought that implied that it wouldn't ask for a password.
So SSH is just for tunneling through this. So while you're pushing, it will not require password, but this is like commit. So you're basically here signaturing your commit. So here the GPG comes into picture. It's using GPG passphrase.
Oh, okay.
So
yeah, my push didn't ask for a GPG key either. But if I go to git config, it also doesn't say that I have one set up, like a sign-in key. But I did, and it's in my account as well.
So did you do this git config?
Yeah, like my GPG key is there. It says it's there, but I also didn't have to put in a password.
Yeah, mine's not there in that config, actually.
So you can use the command git config global user sign-in key.
Okay.
And that is available in
oh yeah. Thanks.
step 0. So if you go through here, you can use this and then do that. Passphrase, then we'll get back to this. Or else at the end of it, I'll personally talk to you and see what's happening. Right now, I can't comprehend right now what could be the issue, because it should have asked you password. But if you have followed the same thing and still are you not getting a passphrase, then maybe there's an issue. So I'll look through it together. So for whom it doesn't show up, you can do this thing. I will show it to you. Please put your own GPG key there. Don't copy the same command. All right, any more questions? So we committed our code. Now let's see how to push it. So let's check if there is a remote added. So right now someone said if you're using SSH key, you can directly push. And the reason for that is basically because you have used SSH method. So that basically is the tunneling method. And now when you cloned it, the origin pointer is set to that SSH URL. And this origin is a pointer which will be a friend, and you will use that pointer to push the code to your remote or to the server side. So the command to do that is git push origin and then branch name. So you see your branch name is master because you're doing everything in master. So I think for others it might be main. See, like just check what it is, main or master. Based on that, you can push to git push origin master. And once you do that, it will count the number of changes, the bytes, and once it's done, it will push it to a branch. And once you have done this, you can go to the UI and go to your repository and refresh the repository. And now you will see there is a file existing, and this is your system, and the branch is either main or master, depending upon how you configured it. If you have added a README, I think it will be main. And now people who have not got the passphrase, if they click on their commit, do they see verified here? Yes, no, nothing.
No, I don't have verified by mine.
Right. So we'll check on this. We'll check on the GPG key together at the end of the workshop. So right now it doesn't affect you. It was just something for you to add up so that in future it will always prompt verified. So we'll ensure that you get that by the end of this workshop. Right now it wouldn't stop you from like working on the workshop.
Okay.
And has everyone got to this step? Is anyone having issues with pushing, committing, or checking the status? Awesome. So if nothing, if no issues, have no questions till this point, we'll go to the next part of this, which is branching. So as I said, normally branches, Anish also explained this, and branches are basically for checking out from your master or main so that you don't disturb that and then work on something. So it could be either a fixed feature or any new code which you want to do. So as you might have your main, and just a question right now, is your branch main for most of you?
It's master in my case.
And others? Yes, you can put that in chat if you don't want to speak up. If you have master or main as your branch. See. So I'll just while I'm talking to that, while I'm speaking about this thing, just assume like if I'm saying master, it's main, and if it's confusing you, please do ask questions, and I'll follow through that. So I have my branch as master. Some of you have main as their branch. It's one and the same, just a different name. That's it. So now when you're creating a new branch, we'll check out a new branch from there. So the checkout command basically is you want to check out to a new. It says you are checking out to a new part, and B means -B means you're trying to create a new branch. So -B is for the branch, and now you want to create a new branch with the feature which you'll be working on. So it's like you can name it my new branch. And once you do that, you can do git branch to see where you are at. So git branch will show you with the asterisk in which branch you are currently present in. So you're present in git my new branch, and some of you should have main and some of you should have master. So there should be two branches as of now. once you created a new branch with git checkout my -b my new branch. Just before we go anywhere, like go before next to the next step, let's like nail down on this checkout. So with checkout, you can switch between branches. So if you do git checkout master or main, you will go back to your master branch, and you can check that by doing git branch. And you see that git branch is the asterisk move to master. And same thing if you do it again to my new branch. And do git branch again, the asterisk will move to this. It's basically saying that you have moved to this branch now and you're working in this branch now. When you check out a new branch, what happens is the information present in that branch is called, it's a new copy of it. So anything present in the master branch is also present here. So there's this question.txt already available here. So now what we'll do is we'll keep on editing this and then doing stuff like doing addition and then making commits to that. So following this, let's answer the question in question.txt and also create another file called random.txt inside the repository. So we first open the question.txt and then answer that. And then you save it with :wq. Once you have saved it, you can open another one. Feel free to use your editors. Feel free to use gedit. Feel free to use anything, Emacs, whatever you use, which you are comfortable with. If not, you can follow me and use Vim. And then create another file, random.txt. We can keep it empty. You can use touch command to just create an empty file. Once you have done this, you can do git status to see what happened. And make sure you're in the branch, my new branch. Please don't work on main or master right now. We will work, we will see like how it goes. So now you're in the branch and you made two changes. One is that you added the answer to your question, and then you created an empty file. And when you do git status, it shows that the question.txt is modified. So Git already knows it's tracking your file, which it knew about, and it already sees that there was a change made to it. So it's showing that you have unstaged modified change to a question.txt, and it also sees there is an untracked file which it still doesn't know about, but still it's present in that repository. So what would we do from here? We would add that, right? So we do git add and those two files. So we do question.txt and random.txt. So just think of this as your source code. So there was a along with that, you wanted to write another code, and you basically wrote a sorting function in a different file. So so now you're adding both of them, and now once you've added that, you can see again status, and you will see both of them are ready to be committed. So you create a new commit by saying git commit -m for message, and then you say added question.txt or modified updated question.txt and random.txt. Once you have done this, if it doesn't prompt you this, don't worry about it. Just you have committed it, and once you do this, you will have two commits in your log. So you do git log, and you'll see two commits showing up. One which was previously done, and then the other one which you just created right now. And if you see, go back and check out to, so if you check out to master or main, you will see git log only with one commit. This is because you're working on a feature branch, and that has the changes, not the master or the main branch. So we'll go back to that, and we'll see the log, and there's again the two changes. So this is how you are working in a branch. Once you have done that, now you can basically use that to merge into master once you have done that. So, but before doing that, let's keep on editing it 1 or 2 more times, right? So we did this, we added it, we committed it, and let's also push that. So we push this branch. Oh yeah, we should push the branch to see how it looks. So we git push origin because we know origin is the pointer. So origin becomes this the destination, and the branch is your new branch. So you're basically saying push to the destination this source file. So this source branch. And once you do that, you should have this and it should say new branch. And when you go back to the UI, you go to your repository, and here's a toggle or a drop down. It's loading for me. For others who's it's already loaded, you will see a drop down here, and there is this your my new branch. And now you see, sorry.
Can I ask a quick question? When I'm trying to push, it's asking for a GitHub user and password, which I'm noticing that it's not doing for you, and it's just saying valid every time that I put it into.
Yes, and that could be if you do it with me, and if you do git remote -v. For you, it might be HTTP here. Is it HTTP here?
Yeah.
Yeah, because you have used the HTTP method instead of SSH method. So so here it was HTTP method. HTTP method always prompts you for username and password. And SSH method will, because you have already set up your SSH with GitHub, it already recognizes you. So that's the reason it's not pushing me. If you want to change that, we can do it right now. Just go to your UI, go to SSH, copy this, do it with me so that you're in sync. So once you've copied, did you copy it?
Loading.
Yeah.
Yep, I got it.
Awesome. So once you have done that, what we want to do is we want to edit this. So because it's already HTTP, you can't do it. So what you need to do is basically first remove that. So this is only for, sorry, I don't get, what's your name? Sorry.
Charlie.
So this is only for Charlie. Others don't follow this because if you have already set up correctly, you don't need to do this step. Only for Charlie. If anyone also is facing the same thing, like Charlie is getting to prompt his password. So that's the reason we are changing it back. So you do basically git remote remove. You're removing that pointer origin. You with me, Charlie?
Yep.
Awesome. So you have removed the origin now, and now you're creating it back. So you do git remote add origin, and now you paste that which you're paste the URL which you have copied.
Got it. All right. Thank
And
you.
you do again git remote -v, and you see it's SSH now.
Yep. Perfect.
Awesome. So as everyone is at this stage where they have pushed it, and now you can view your branch in the UI, you can see there is 2 commits right here. If you see there are 2 commits, and you can click on them to see what are the 2 commits. And you see they are verified based on the GPG key. Same thing. Just wanted to show you this. And if you go back to the branch and you see the master branch, there's only 1 commit because we have just made the change there. Everyone with me till here? Any questions? Awesome. So everyone is here till this point. Now what we'll learn is about squashing. While presenting, we said there's squashes. Squashes is for squashing multiple commits into one. So we will go through that. So we will go through this together. So please follow me. And if you're missing out somewhere, just let me know so that we can go back and do it together. So first thing, what we'll do is we'll add multiple commits. So let's do at least 2 of them and then try to squash them, right? So what we want to do is we'll go again to the same branch. We will edit question.txt. Question.txt, and then you can ask another question. Like, feel free to put anything. Like, no, it's not necessary to put this thing. Just for it, I just kept it for example. So you paste that, and now you can save it. And once you've done that, you commit that. So just follow through. You have edited the question. What do? We do status just to see what happened, and you say there's a non-staged change. So how do we make it staged? We add that. So we added question.txt ready for commit, you will commit that by doing git commit -m, m for messaging, and then say updated question.txt, and then save it. Now you see there, if you do git log, you will see there are 3 commits. We'll follow through again. We'll do some more edits. We'll go to question.txt again. We'll write something like what's your favorite, and then just write here and something. Just save that. You see again, you look at status. So git status is your friend. You always, it will help you to know, oh, there's some changes and you haven't forgotten to commit that. So you can do that. So you can do add, we need to stage it. So we'll stage that. We will commit that with say updated again. And now there should be 4. So 1, 2, 3, 4, you see 4, like that, 4. With me till here, everyone? Awesome. So now we'll go and squash it. So this is where I wanted to take a minute so that everyone is here, at least have four commits. It doesn't matter what you have done inside, it's just like commit matters right now. Just think it as you're editing your source code. You've made some changes to a sorting function, and now you are made another change and another change, like that, 4 changes. So we are till this point now. What we want to do is we see that our master branch is at the only first commit. Now we want these 3 commits to be squashed into 1. How would we do that? We have 2 methods. There is one method is to do git rebase. Then you can do this hyphen tilde hyphen I for interactive, and then you do head and then tilde 3. I normally don't use this because for now you're having only 3 commits to squash. But if you had 50 commits or 12 commits or 30 commits, like it's hard to know the number. So that's why what I prefer is the easier solution. So suppose, for example, I want to squash these 3. Then what I'll do is take the commit hash of the one below it. So I want anything before this to be squashed into 1. So I'll just take this one, select this one, copy it. With me till here, you copy this one, and then go back and do git rebase hyphen I to go into interactive mode, and then paste that SHA. Once you have done this, you press enter, and it will take you to an interactive mode. So here you are in a nano. Normally it takes you into a nano editor. This is called a nano editor. And once you're here, what you need to do is you see 3 commits. First the add one, then we updated it twice. Normally what happens is you always leave the first one. First one always stays picked, and rest you will squash. You see here are the methods to do it. So right now we are learning squashing. So we will use squash. So either you can put S or squash. So you edit this with hyphen I, you make it S, or squash, you write full squash, or you can just put S. So we always pick first and squash the rest. Pick first, squash the rest. So you have done this, save this. Same way you save in the VI, and you do that. And once you save this, it will take you to this file. Now what's it asking is, you had 3 commit messages. What all commit messages do you need? So either you can leave that and say, I want all the 3 commit messages. So it will, when it will squash, that commit message will have all these 3. So let's try that. I'll try that. If you want to edit, you can edit too. So normally what happens is you remove the other, you basically remove all these commit and make one single commit message so that it's more clean. So I'll save this. Once I've saved this, now if I do git log, there should be only 2 commits. One which was from master, and then the other 3 got squashed, and you can see all these 3 are showing up in its message. You following? Any questions till this point? Everyone got this? Please don't hesitate if you have missed out. I am more than happy to go through it again. And these are the things which will come, which will be very helpful for you while working, because a lot of reviewers might ask you to squash your commits before making a pull request. So like this is essential. So please do ask questions.
So where do we put the squash? Like in that file once we do rebase, it opens that file in Nano.
So when you did this rebase, it took you to a file. So I'll just go through it really quickly. So yeah, just 1 second. So you see there is one extra commit now, and now I'll try to squash it with you. So you copy this one. We want this two to be squashed. I copied that. Now I do git rebase -i interactive mode. I paste that SHA. It took me to this file. This page is where you are asking where would I put the squash. So I always pick the first. I will never change the first one, and the second or the third and the fourth, all of them I'll make it squash. So either you write S or squash. And once you have done this, you save this file. You with me?
Yep. Thank you.
So you save it, and it will ask you again to have a commit, like what all you want. I don't want this, so I'll delete it, and I'll save it back. And if I look at the commit, I'm back to the 2. You guys with me, everyone? Any questions? Awesome. So now we have squashed it. We have learned how to squash. Now we'll push the branch. So what do you think when we push? Will it let us push the branch again to GitHub? I will assume every one of you are saying no, because that's the right answer. It will not let us push because it already knows there was 2 commits now, but right now what we did is we edited the second commit. So now it will be confused and will say, I see there is a change of commit. I don't know how to do this. So it's basically prompting you this error, fail to push. I hope everyone is getting this error right now. And now here we learn something called a force push. So when you do a force push, you always need to remember you never force push to your master branch or an upstream master branch or a main branch. You never force push to a main or a master branch. Those will be protected with a lot of things, but you yourself should know that you are never going to push a force push to those branches. So you always make sure you are on a different branch. As you can see with this asterisk, I am in my feature branch. So I will force push only from here to my feature branch. -f will say force push. So git push -f means force push origin my new branch. What does the force push do? So if you look back to your branch here in the UI, there are 2 commits. And what happened was this commit got squashed into another commit. So the shard got changed. The literal meaning of this commit got changed. So that's why it's saying, oh, I can't enable you to push this to this branch because there is some uneven changes. So, but you know that you squashed it and you wanted it to be squashed and you wanted the commit to change. So that's why you're saying, I know what happened and I want to force push it. So you do force push and it will let you push to that branch. And now if you refresh this page again, you will see this has been changed and the commit message has been changed. The SHA has been changed. And whatever changes you made to your file is existing there. Sorry, this branch. So whatever changes you made is existing in your branch. Everyone with me till this point? I will assume you all are. And if not, please let me know so that we can work through together. So next thing is knowing what's the difference, what's the difference between the 2 branches. As you can see, we added a new file, we changed the whole question.txt in our feature branch. And when you check out your new main branch or the master branch, you don't see the random.txt or you don't see the changes which are made into question.txt. So what do we want? If you want to merge them together and you want your changes to be in your master or the main branch, how would you do that? There is a method. So to do it in the local, there's a method which is called git merge. So you go check out your master branch or check out your main branch. I hope everyone is here. You can check. You can make sure you're in your master or main branch by shifting your asterisk. Once you're here, you basically write git merge and the branch name you want to merge. So we want to merge the my new branch to this master. Once you click that, now you will see you have two commits in your master branch as well. And then you can push it to your master, and it will. And you don't need to do a force push, and never do a force push in your master branch. And you can do push, and it will enable you because this new commit was not existing on upstream or in the remote GitHub, so it will enable you to push that. Everyone with me? Any questions till this point? Till now, what we have learned is how to check out to a new branch, how to add unstaged files, how to commit staged files. Once we commit, how to push that to a branch. Once we have pushed that to a branch, how to add more commits and squash them together into one single commit, and then push it again to the branch and then merge it in your local. There is a bonus step if you want to try to do it. You can learn how to delete the branch, and you can see how to clean up that branch. It's excellent that everyone is following and has no questions. So I'll move along to the next part, which is forking. And here we need to spend more time. So that's why I'm trying to go through this. So these are the important steps, and because now you're going to really learn how to work with projects. So this is where you need to start with. So till this point, you have learned everything about Git. Now from here, you are learning how to contribute to projects. So forking an upstream project. So go to the URL. You should be already in this project. From here, you see a button called fork. Click on that. In here, it will show up your name. As you see, it's already there. It shows Harshad has already forked this repository. You can fork that. And once you fork that, it will take you to this, your own forked version of it. Everyone here? Awesome. I think everyone is there. And then again, what we'll do is we'll clone this project. So we copy the SSH method to be convenient. We go to terminal. We go back to we'll come out of the my awesome repository directory. You can do cd ... basically means cd, change the directory to this, and you come back to it. Now you will do git clone. We all know the command, it's git clone, and then you paste that URL. Now tell me what would be the origin pointing to, if anyone wants to answer that question. I see no one likes to answer my questions, so yeah.
Don't be so sad. Oleg has.
So it's no worries. I'll show you what happened here. So now because we cloned it from our own fork, it has forked, and it would be pointing to my fork. The remote will be pointing. The origin will be pointing to me. So the pointer origin is pointing to my URL. Everyone with me till this point? You have forked. Now you're cloned, and you check the remote, and it would be forked. It is basically onto your forked. It is basically pointing to your fork. Now, this is what you did. You cloned it, and you have it, and this will become your remote copy of that particular project. Now you need to set up the upstream. The upstream is this repository which you have forked from. So you go to this repository, go to the code part of it, copy the HTTP or SSH. You can do both of them, either of them, whatever you want. Just copy one of them, and then go back to the the your CLI terminal, and then we will add the remote. So I showed you the command to add the remote. It's git remote add upstream, not origin anymore. It's upstream. We are setting the upstream. So git add remote, git remote add upstream, and then paste the command, the URL which we copied. It's AICoE Workshop Intern Bootcamp. Once you have done this, you can check again git remote, and you will see pointer origin and pointer upstream. Pointer upstream is pointing to the AICoE, pointer origin is pointing to you. So this is how you segregate between you or copy and the upstream copy. So we have covered the step 2. Now we are moving to step 3. Step 3 is to add a feature and now create a branch from it. So we all know how to create a branch. So it's git checkout -b and feature, like you can name it anything you want. There is a file called attendees.list, attendees.txt. You can open it up, edit it, and put your name and email ID. And this is how we know that you're working on it. So you will add your name and email ID, and then you know what to do. You basically check for status, and there is a unstaged file. You will stage it by adding that file. Then you will commit that file with commit message, attended workshop, and then push it to your fork, git push origin feature branch. So a lot of times what happens is because you're forked and you're cloned, a lot of you would think, oh, why can't I work on my master branch? You always need to intact, or you need to maintain your master or the main branch with the upstream master and main branch, so that you can do a clean checkout into a new feature branch. You always work in a feature branch and then make a pull request from the feature branch to the master branch. In that way, you have a clean, nice flow, and in that way, you will never spoil your flow, and your master branch or the main branch will always be intact with upstream. And git pull, you can do git pull to get the new commits from upstream to your master branch. So here we are going to show you how to do it from the feature branch, like pushing and then doing that. Yes.
I have a question. So, can you show me again how to change your pointer to the original to your upstream again? Can you scroll up a little bit?
Yes. So when we cloned it to our fork, and the fork when you do git remote -b, it will show you origin is you, and then to add upstream, you basically do git remote add upstream and the URL of the upstream.
Okay, so you copy that the SSH again and then add upstream. So that upstream is it a tag or?
It is a pointer. So this is a pointer. This upstream is a pointer exactly as an origin.
Okay, got it. And then so after that you can push to upstream.
Say it again.
So like I just want to know, like, this upstream pointer, is that what we use to like push to, or like what's the feature for the?
So technically you wouldn't push to upstream. Very rare that you'll push to upstream. The feature here why we added this is to pull from it. So if someone made changes in the upstream and you wanted those changes in your own fork or your branch, you will do it with this this pointer.
So every time someone added something, they can.
So I'll show you this. So for example, there is in AICoE CI, Anish made some changes, and I had forked my branch on suppose today, and Anish started working on it and made some changes tomorrow, day after tomorrow, and he keep making that. And after 5 days, I realized I have made some new changes and I want to push it now and make a pull request to it, and I also want it to emerge. Then I see Anish made some X number of changes in these few days. So this pointer will help me to pull that changes. So you do git pull
Okay, got it, got it.
upstream master.
Okay, got it.
Awesome. Yeah. So right now here, what we did is we created a feature branch and we edited a file. We created and then we committed that changes and now we pushed it to the feature branch. All if everyone is with me, they would have finished this part. Now, if you see your work, your own fork, you have an extra branch here. As you can see, it shows me I have 1 commit ahead and 14 commits behind. So I need to do a rebase pull because I have 1 commit extra, and between these 2 commits, this one and this one, there are 14 commits missing. So I want them. If I do git pull, then what will happen if I just do git pull is all those 14 commits will come on top of this. But I don't want that. I want all those 14 commits to come below this because I want this, which this is not existing in the upstream. So I want this to be merged. So what I'll do is rebase pull. This is the next step which we're doing. So there are 2 steps to do that, 2 ways to do that. One is to fetch from upstream. So we are doing git fetch upstream. This basically is doing what it is doing is fetch means fetch all the metadata from upstream. So all the content, it knows, okay, there is X number of changes. So copy that. So now it knows there's in the main branch, there were some changes. Now what I'll do is rebase with that main branch. So I'll do upstream/main. And I see there is a conflict. So I need to resolve that. So I'll open the attendees.txt and there is X number of people already added there. So I'll delete. I don't want them to be deleted. So I'll keep there. So this is where you will see in day-to-day life, there is commits from there are content change from others and you don't want to spoil them. You just want your content to add it to it. So you basically edited that. So now when you pushed, so you saw I had, okay, I'll show you back again. So when there was conflicts, I opened it up. It showed me the header is pointing to this. So when the head means the upstream has these changes, and my commit, this commit SHA and this commit has this changes. It's asking, do we want this or do we want this or do we want both? So we want both. So what I'll do is I'll remove the first line. I don't want this, so I'll remove this line. I don't want this, I'll remove this, I'll remove this. So everything is there which I require. So I'll save this file now, and now I'll do git add. Or first I'll show you what's happening. If you do git status, there is a modified file. So you will git add it. And now you will not commit it because you are in a rebase state. You can see, if you do this, git status will show you are in interactive rebase is in progress. So you will not commit it, you will just do git rebase. And the command is already given here. You just need to do git rebase continue. And save it. And now if you see, there are 14 commits already here. I'll push it to my branch. Do you think it will let me push? It will not let me push because I have some conflicting change. So I need to push it. Once I push it, you will see this changing to only 1 commit ahead. Let me refresh it, 1 commit ahead. Now what will I do is I will say open a pull request from this branch. So I will go to the AICoE workstation. I'll go to pull request. You see a lot of people have already done it. So I'll open a pull request, compare with fork, use my fork, use my feature branch, and you will see this. Once I open pull request, I can request Anish to be the reviewer. Anish can review it. And now once he reviews that and all the CI checks, so there would be a bot who will run the CI checks. It depends on teams. Once that happens, Anish can say he likes my changes, he's okay with it, and he can merge it.
So Harsha, do we cheat and I merge your PR first? Do we merge the other PRs first?
So do one thing, merge someone else's PR first, so that I can show you what will happen here.
Sounds good. All right. Cho is the lucky person to get merged.
Awesome. So
they already have a conflict. Sorry.
So you can check someone else's. I think this one's.
It looks like actually everyone has a merge conflict.
So no one pulled properly or no one cloned properly?
So
yeah, they all removed someone else.
I pushed. I think I pushed after a lot of these people. Yeah. For some reason, the new ones aren't showing up. Oh, I just had to refresh. There you go. No, I'm no. All right, we have one PR that is going to get accepted. So the one from Oleg.
Yeah, just merge it.
Yep, just merge it now. All right.
So as you can see, Anish merged someone's PR. Their content went in. Because of that, we also edited the same file. And now it says there's a conflict in this file. What's the conflict? You can see here, someone else added something and we are missing them. So we need to rebase again and get their commits back. So what's the difference here in my branch and the upstream branch? After this commit, there is another commit on top of this. So I want to rebase again so that their commit comes below me and my commit stays on the top. So I'll do it again. I showed you a method which was to fetch and then fetch upstream and then rebase upstream. Now I'll show you a simpler method. You can just follow this. You can do git pull hyphen rebase. So we are saying pull with rebase, and we all know from where we need to pull it from. We need to pull it from upstream and main. So once we do that, it will show you the conflict which it showed in upstream. We edit that. We see someone's conflict was added, so we edit that, and now we'll save it back. This is how I want it, and then I add the file. I rebase continue. I don't commit it. I just rebase and continue. Once I have done this, I'll push it back. It will not let me push normally, so I have to do a force push to my feature branch. Once I've done that, if I refresh, I don't need to do anything because I had already updated my pull request. So if I see, because once you open a pull request, it adds to your branch. So anything you push to your feature branch, it will automatically reflect in your pull request. As you can see, my commit is already reflecting and the conflict message is gone and now it's ready to be merged. So this is how you'll fix the rest of the things. So for example, if you look at this pull request, they have a conflict. So let me just show you, because I have admin privileges. I can do it in this report. I can change their pull request. So what's happening here is we want their changes. We want this. We want this. So once someone whose pull request was this, they do the same change. They go rebase pull. So they first do git pull rebase, and they will get these conflicts. They will resolve it by opening it up, editing it like this, saving it back, adding the files, rebasing it, continuing the rebase, and then pushing it to their feature branch. Once they do this, their pull request will also get cleared, and then it will be also ready to be merged. Please feel free to ask questions. I think that's the end of it. We have covered the PR as well with this. If now you have any issues, let me know, and we'll go through it. Let us know, and we'll go through it. If not, then I can go through the extra resources. Any questions?
I don't have a question, but I just wanted to say I think you did a great job walking through this. Thank you so much.
Welcome. Thank you. Thank you for attending.
Hi, Harshit. So once you do the pull request and once you merge with the master branch, then you can delete the working branch, right?
Yeah.
Like a new branch. Okay.
Yeah. So I have this is my pull request. It got merged, so I can delete this branch, and I will not have this branch anymore.
Okay.
So the page is not found. Yeah.
So this would be the usual practice, like in the work.
Yeah, if you feel like cleaning your branches, yes.
Okay. Thank you.
So yeah.
Sorry, I'm just gonna jump in real quick. What actually is that branch still called master?
This is my fork.
Okay.
Branch, yeah.
So just to clarify, like generally speaking, a lot of open source organizations and Red Hat are pushing towards using main as before terminology. So in general, try saying main before master. It's not like, yeah, just as an inclusive thing. Sorry, go ahead, Harshad.
Oh, hi. If you have any questions, feel free to ask. If not, we still have 11 minutes, I guess. So I'll just go through some extra resources for who is interested. As you can see, you see in my terminal, you see this is branch always shows up here. And I have some auto correction, which always shows up. All these are plugins and they are called ZSH. And you can also have them. There are different fonts and themes for them. I am using the default. I think that's not the default. It's a basic one. It's called Gento. You can have other ones. And it is also defined in this. If you go to this file called extra resources, it's defined here somewhere. ZSH. Yeah, so my ZSH, you can go through this and read through it and configure what you want. So this is there would be a file called, and then there will be auto completion, like things like this, and you can use what you want. So I have auto completion, auto suggestion, syntax highlighting added to it. So please read through that, and if you also want features like this, you can add those plugins. So that is my ZSH. The rest of the things, there is a cheat sheet for all this. If you can't remember the commands, and then if you want more depth knowledge of more other things, you can do that. And the rest of the things that we have covered in the presentation. So just feel free to use it. Have fun. And if you have any questions regarding Git, or if you're stuck somewhere, always feel free to reach us. If you have no other questions, let me know.
I have a different question about this thing. So do you know how to access the terminal from the browser, like the Jupyter Hub and all? Get into the data hub. Like
I mean, that I could show that, but it's a different question. Maybe on first you have Jupyter Hub presentations going on. You can see there. There is an option for terminal. You can go for that.
Okay.
If you're asking in Git, you will always get that option only in pull request. In pull request means you can also get it in edit. You can go here. You can change your files from here, or you can go to your file from here, and there's a button to edit. The pen button.
Oh.
You edit it, you edit your changes, then you can commit from here as well.
Okay.
I personally don't recommend using UI, but it's all up to you guys. If you like using UI, you can do everything from UI.
Yeah, I was actually asking about getting the browser extension for the terminal, because I think that's way it will be suitable for my case, I guess.
Yeah,
I'll try this again with the browser terminal.
Yeah, this one. Do you mean by this? Or
no. Once I have the Jupyter Hub in the browser, then I can access the terminal from there and do all these GitHub operations from that.
Yeah, it will be the same once you have the terminal. It's pretty much the same thing. Yeah.
Okay, thank you.
Awesome.
To also just add to that, Surya, I think we also will be having a session, as Harshad mentioned, next week, which is more on deep dive on Jupyter Hub, and they will definitely go over how you can set up Git within the Jupyter Hub terminal as well.
Okay. Yeah, looking forward to it. Yeah, thank you.
Yeah, no problem.
Awesome. Any more questions, guys?
Yeah, I have a question. So just to clarify, whenever you do pull requests, you do it on your repo, like your fork on the on your profile, not on the upstream profile, right? There's no way you can do a pull request directly on the upstream profile. Is that correct? Or
no? So if you go to the upstream project, you see this is an AICoE ECI, and then you go to new pull request. This will always show up for you as well. Then you can compare with your forks, and then you pick your fork, and then you can make your changes. I recommend using always the feature branch. I have deleted it to show someone, but my feature branch will show up here, and you use that feature branch to open pull request. That's only because you always want to match up your main with the upstream main, and you want it to be intact so that you can check out whenever you want. Check out to a new branch.
So when I do a pull request directly from upstream, I don't see my branch. I don't know why.
So did you click on compare across forks? Do you see do you see head repository as your name?
Yep.
Okay. Yeah. Sorry, it was just breaking to me. I couldn't hear clearly. Yeah.
Okay. Yeah. Got it. I got it. Thank you.
Awesome. This is how you open pull requests, and reviewers will review it and comment based on that. And also one more thing. So for example, I see there is this change, and I could, as a reviewer, I can suggest something. Oh, it should be this way, that way. So it will show up here. And that's how people review it, and you will have comments here saying, oh, these are the things to be managed. Awesome. If nothing else, I would like to help the people who didn't get the GPG key set properly. And thanks for attending. Just for formality. That's like. Thanks, guys. So can I talk to those guys who didn't get the GPG thing correct?
Yeah.
Or sorry, I actually think I got mine to work, but thank you.
Awesome. And anyone else?
Yeah, when I try to, so if you, I